We humans, we've always been explorers. We've climbed the highest mountains, dived into the deepest oceans, and even ventured beyond our own planet. But did you know that Earth has an almost invisible atmospheric layer that blends into space? It's called the exosphere, and it's the most mysterious part of our atmosphere. Out here, the laws of physics seem to bend, and the boundary between our world and the vastness of space becomes blurred. Today, we embark on a journey to the edge of our world to explore the mysteries of the exosphere and uncover its secrets. Imagine you're rocketing away from Earth, leaving behind the blue skies and fluffy clouds. You pass through the stratosphere, home to the ozone layer, and then the mesosphere, where meteors burn up. Welcome to the exosphere. Starting roughly 500 to 1,000 kilometers above the surface, the exosphere is the outermost layer of Earth's atmosphere. Unlike the lower layers, the exosphere is a realm of incredible thinness, where gas molecules are so spread out that they rarely collide. Down here on Earth, we take air pressure for granted, but in the exosphere, there's practically no air pressure at all. The exosphere is primarily composed of hydrogen and helium, the two lightest elements in the universe. The exosphere gradually fades away, its atoms becoming fewer and farther between until you're officially in the realm of interplanetary space. Now you might be thinking, if the exosphere is so diffuse and spread out, can we even call it a layer of the atmosphere? And is Earth the only planet with such a unique feature? Well, the answer is a resounding yes and no. Let's take a look at our neighbor Mars. The red planet also has an exosphere, but it's much thinner than Earth's, with a composition that's dominated by carbon dioxide and argon. Next, we travel closer to the Sun, to Mercury, the smallest planet in our solar system. Mercury's exosphere is even more extreme. Even our own Moon, despite having a surface gravity only about 1/6 that of Earth's, has a tenuous exosphere. The Moon's exosphere is constantly being replenished by a process called sputtering, where the solar wind bombards the lunar surface, knocking atoms and molecules loose. Exospheres are as diverse as the celestial bodies they surround. Their composition, density, and even their very existence depend on a delicate balance of factors, including the planet's gravity, temperature, and the composition of its atmosphere and surface. Now let's get back to Earth for a moment. Imagine for a second that you're an astronaut, strapped into a rocket, preparing to leave the familiar embrace of Earth. As you ascend through the atmosphere, you pass through each layer, feeling the pressure and density change around you. But what happens when you reach the exosphere? Well, in a sense, you're already in space. The exosphere is so thin that spacecraft passing through it experience very little resistance. In fact, the International Space Station actually resides within the exosphere. The exosphere's low density makes it an ideal place for spacecraft to orbit. The exosphere isn't just a celestial highway, it's also home to breathtaking natural phenomena like the auroras. So, the exosphere is like Earth's invisible boundary with space. A place where the air thins, atoms escape into the void, and spacecraft begin their journeys to the stars. It's a realm of wonder and mystery, a constant reminder that our planet is not an island in space, but an integral part of a vast and interconnected cosmos. As we continue to explore the universe, the exosphere will undoubtedly play an increasingly important role. It's the gateway to other worlds, the first step on humanity's journey to the stars. What do you think? Should we explore it further? Drop a comment below, and don't forget to like, subscribe to Audibly, and hit the bell icon for more amazing facts.